Good evening, everyone. Today we are going to see about fundamental of robotic manipulator. This subject is for final year mechanical students and final year automobile students. Myself is Jinish, Assistant Professor, Department of Mechanical Engineering, Bethlahem Institute of Engineering, Karungal. Before entering the subject, we have to know about what is automation and what is the necessary of automation, this kind of stuff. So first, a machine with a hidden mechanism that initiates the movements of human beings or animals is called automation. A machine with a hidden mechanism that initiate the movement of human beings or animals. Ancient people tried to build mechanical objects that looked and moved like human and animals. Such machines were known as automation. Such machines was known as automations. Automations can perform only a single set of actions. These self-operating machines were quite common even in ancient times. Automations cannot change any of its movements and has no intelligence of its own. There were not any electronics or stuff like that involved in these. They have been simply used mechanical principles, right? So we we have to understand what is automation and what is the definition of automation. So definition, what is the definition? What is automation? Automation is a technology that is concerned with the use of mechanical, electrical and computer based system in the operation and control of production. The use of machinery that can be moved by its own power. So this is the definition of automation, right? Automation is a technology that is concerned with the use of mechanical, electrical and computer based system in the operation and control of production. The use of machinery that can be moved by its own power, right? So before entering the subject, we have to know and study about the uh, robots and its types and parts, these kind of stuffs, right? So first of all, we have to study about industrial robots, the method to specify the robots, types, drives, technology, and motion controls and various application of robots, specifications. So these are the things we have to study in your first unit, right? So um, so these are some difficulties faced in human beings, um, for their working. So that is why we are invented and broadly suggest robot for such extreme temperature conditions and unpredictable and uncomfortable natural conditions. These areas are humans struggling to work. So these areas machines, this area not affected machines. So we preferred robot or automated machines for doing work, right? So radioactive areas and the space stations, and some medical field and the heavy earth moving equipments. These are the areas human can struggling to work, but machines or robot is not affected such a things. So that's why we preferred robot, right? Automations. So reason for using robot, but the central reason is to eliminate a human operator. The most obvious reason to save labor and reduce cost. This is one of the industrial robots we are used in industrial industries. So they to save labor and reduce labor costs, right? um, some areas perfection, some work need perfection. There we used uh, robots, right, for high efficiency of working. These are some examples. So first, here robot is considered as an industrial robot called as robotic manipulator or robotic arm. This arm is roughly similar to human arm. It is molded as a chain of rigid links interconnect by flexible joints, right? So here we have a diagram. Here it is wrist, forearm, elbow, upper arm and shoulder joint like a human hand, right? So here we have a gripper and tools, right? Gripper means the handle or wrist connect an effector to forearm. Wrist wrist is this is connected with forearm or end effector. End effector may be a tool or its fixer, right? Or gripper or any other device. Gripper is generally used to grasp or hold an object and place it at a desired locations. Grippers classified as mechanical grippers, vacuum or suction cups, magnetic grippers, adhesive grippers, hooks, scoops, and so forth. Right? Tools: a robot is required to manipulate a tool to perform an operation on a work part. Here, the tool acts at end effector. Spot welding tools, arc welding tools, spray painting nozzles, rotating spindles for drilling. These are some grinding machines. These are some examples about tools, right? So automation in robot, another important topic, another important subtitle is automation and robot. So now already I said some one definition, right? What is automation? Automation is a technology that is concerned with the use of mechanical, electrical and computer based system in the operation and control of production. The use of machinery that can be move its own power, right? The same thing is here also, right? So now we move to types of automation. So there are three type of automations. Here we mention only two only: hardware and software automation. And hardware automation and software automation furtherly divided into two types. So totally three types of automation is there, right? One is fixed automation, another one is programmable automation, and another one is flexible automation. This programmable automation and flexible automation is similar, but little bit different. So I put in three types, right? Fixed automation, programmable automation, and flexible automation. So what is fixed automation, right? Fixed automation is a system in which the sequence of processing operation is fixed by the equipment configuration. Fixed automation is also called as hard automation. Fixed automation is the integration and coordination of many such operations into one piece of equipment that makes the system complex, right? So features, what are the features available in automation? In fixed automation, high production rate and automated material handling and relatively inflexible in accommodating in product design, right? Every automated machine have its own limitations, right? Here we have some two limitations. One is high initial investment, another one is fixed automation is used to when the volume of production is very high, right? So these are some limitations and example: mechanical assembly and mechanical transfer line. These are working in the working under the application of fixed automation, right? We are going to see about degrees of freedom and some more chapters, right? So degrees of freedom, DOF, is defined as the number of input parameters independently controlled, each joined by motor. Degrees of freedom of a rigid body are defined as the number of independent movements which has the number of independent position. The number of degrees of freedom is equal to the total number of independent displacement or aspects of motion. The number of joints determine the manipulator degrees of freedom, right? Degrees of freedom is a term used to describe a robot's freedom of motion in three-dimensional space, especially the ability to move forward and backward, up and down, and to the left and the right. For each degree of freedom, a joint is required. A joint requires minimum 6 degrees of freedom to be completely versatile. So this is a very very important point here. Robot requires minimum 6 degrees of freedom to be completely versatile. Its movements are clumsier than those of a human hand, which has 22 degrees of freedom, right? So this is a human arm. Already we discussed in the first video. So here the coordinates, three coordinates, x, y, z coordinates as there. So the number of degrees of freedom defines the robot's configuration. For example, many simple applications require movement along three axes: x, y, z, right? So these are the coordinates: x, y, z coordinate, right? So first degrees of freedom and second degrees of freedom and third degrees of freedom. So first degrees of freedom is x-axis and second one is z-axis and third one is y-axis, right? Thus a minimum of 6 axes are required to achieve any desirable position and orientation in the robot's work volume or work envelope or workspace, right? There's a minimum 6 axes are required to achieve any desirable position and orientation in the robot's work volume or work envelope or workspace. So this is a ellipse type of a shape. Already you would have been studied in your engineering graphics. So the locus line, right, locus point, already you discussed in this same. So the locus of the points in the three-dimensional space that can be reached by the wrist by the various combinations of the movements of the robot joins from base up to the wrist is called the gross work envelope of the robot, right? This is a workspace. This robot is use work this locus point, right? The robot motions are accomplished by the means of powered joints, right? The rigid members connected at the joints of the robot are called links. It's a very very important thing. Some terms you could study it in this subject, because it is totally different from other subjects, because it having its own terms, links and input link, output link, signals and actuators, end effector and grippers. These are some technical terms we are used in this subject, because mechanical and automobile students not familiar with that, right? The rigid members connected at the joints of the robot are called links. In the link joint, link chain, the link closest to the base is referred to the input link, right? And the output link is the one which moves with respect to the input link. So this one is prismatic or linear joint, right? You have to see the arrow now. So this could be moved in linear direction. If you take this say x axis, so this move in forward and backward direction of this is a linear motion, right? There are basically two types of joints commonly used in industrial robots, which are prismatic or linear joints. It is denoted by a symbol of p, which have sliding or linear motion along an axis, right? Another one is revolvate. Revolvate is denoted by a symbol of R, capital R, which exhibits the rotary motion about an axis, right? So this is a symbol of rotary motion. So it could rotate and in 360 degrees, right? The links are aligned perpendicular to one another at, at this kind of joint, right? The rotation involves revolution of one link about another, right? Based on the physical configuration of the combination of the revolute or prismatic joints for the three major axes, a particular geometry of the work envelope is achieved. The table shows some of the most common robot work envelopes based on the major axis, right? So already we saw the axis, right? Just a minute. So this first one is x-axis. So second one is z-axis, and third one is y-axis, right? So I move to the table now. So this is axis 1, this is x-axis, and this is only the z-axis, and this is uh, y-axis, right? Total revolute. So this five type of motions, right? Movement. So in robot anatomy, this five types are available, right? One is Cartesian, another one is cylindrical, the third one is spherical, and SCARS. Cara means selective compliance assembly robot arm, right? This is a short form of selective compliance assembly robot arm, right? And articulator or polar, right? These five types of robot anatomy is available. So in Cartesian type of anatomy, we have p three. First axis means x-axis is a linear movement only, right? Linear movement only. Z-axis also linear movement, and axis 3, y-axis also only we have a linear movement only, right? So revolute or rotational movement is not available in that Cartesian anatomy, right? Another cylindrical, we have axis 1 x-axis, we have a rotation, and another two axes, z-axis and y-axis, we have polar and only linear movements, right? So we have only one rotation revolute moment, and spherical means axis one x-axis and axis 2, which is z-axis, we have a rotational motion, and in axis 3 we have linear motion only. So in total spherical type of anatomy we have one two types, two revolute and SCARA, that is, I already spoke, the selective compliance assembly robot arm. We have the same of spherical type of anatomy. We have two rotational motions and one linear motion. In articulated type, we have three axis rotational motions, right? X-axis, Z-axis, and Y-axis. In all three axes, we have rotational motion, right? So this is a image of Cartesian geometry or robot arm, right? They have only linear motions, so it could move like that, and it could move like that, and it could move like that, right? This is only a linear motion, so it is called Cartesian gantry robot arm, right? So this is a what are the special points are there? Cartesian gantry robot arm robot, which Cartesian configuration consists of links connected by linear joints.